So we're looking today at transformations and congruency. So just how, when you transform something, it affects the original shape compared to the new shape. So two things we're looking at is whether or not it preserves congruence and orientation. So when you say preserves congruence, it means after we transform it, is it still the same shape or the same figure? So same shape and same size. And then we say preserve orientation, we want to know after we transform it, is it still facing the same way? So we have one more chart here, so if you want to pause and copy this down, wouldn't kill you. The basic idea, so our four transformations: dilation, translation, reflection, rotation. Of those four, the only one that doesn't preserve congruence is a dilation. Because if you think about it, when you dilate something, you're either making it larger or smaller. So if you change the size of it, it will be similar, but not congruent anymore. Okay? And then the only time when that wouldn't be the case is if you're dilating by a scale factor of 1, but that's not really a dilation at all. Okay. And then preserving orientation. So we have 2 yeses, 2 nos. If you dilate something, it gets bigger, but it's still facing the same way because you're only multiplying the points. So they're all still, they're either getting larger or smaller, but they aren't going in a different direction. So it does preserve orientation. When you slide something, you just move it, it's still facing the same way. The two that don't work are reflection. So when you flip it over, right, your mirror image doesn't look exactly like the original because everything's backwards. And when you rotate it, obviously it won't be facing the same way because you turned it. And then one more case where it wouldn't, where a rotation would actually preserve orientation is if you rotated it 360 degrees. Because if that was the case, you would end up right back where you started. But again, if you rotate something 360 degrees, did you really transform it? Okay, so let's take a look at a couple of examples. So all your questions are going to kind of look like this. So triangle ABC is transformed to create a new triangle. Which statement is true? So let's just go to the answer choices. So a dilation will preserve congruence but not orientation. So what does it say? It says a dilation will not preserve congruence and will preserve orientation. So that's definitely not right. Translation will preserve orientation but not congruence. Well, we said translation preserves both, so that's wrong. Our reflection will preserve congruence but not orientation. So let's see, reflection, congruence, yes, orientation, no. Hey, that looks pretty correct. But we check all of them just to be sure. So rotation will preserve congruence and orientation. Well, I know that's wrong because if I turn it, it's not going to be facing the same way. So the best answer here is C. Let's see, select all the following that preserve congruence. So if I go to my chart, everything preserves congruence except for dilations. So I know it's going to be a reflection, a rotation, a translation, and not any of the dilations. Not too bad. Let's see, which representation does not preserve congruence? So we just said what does not preserve congruence is a dilation. So that's what we're looking for, but it doesn't give us words, it just gives us rules. So we have to remember what we've learned about transformations. And we got to know, if I look at this rule, what kind of transformation is happening? So if I'm multiplying by a number, well, there's our dilation. Look at that, we got the right answer right away. Just for funsies, just go through the rest. So let's see, plus 3 minus 2. The only one that adds and subtracts is a translation. Let's see, xy to negative xy. So x and y didn't flip places, but one of them is negative, which means this is a reflection. And then xy to negative yx, that is, since we flipped x and y, that's a rotation. So hopefully you have the charts from the past couple days in case you forget what these rules represent. Let's see, which representation preserves orientation? So we know the only things that preserve orientation are dilations or translations. And I ran out of room. You get the idea. So what we're looking for is either a translation or a dilation. So xy to x negative y, that's a reflection. Start abbreviating. X plus 3, y minus 2. Hey, that's the same thing we had up here. Let's say translation. So this answer looks pretty good. Let's just check the rest just to be sure. Xy to negative xy. Oh, the rest of these are just the same. This is a reflection and this is a rotation. So the only one that actually works here is B. Now that explains why they changed the answer A. Like B, C, and D are all the same, but A has to be different because if there was a dilation here, then you would have had 2 correct answers, and then you would have panicked. All right, I think that's about it. Everything else is, oh, okay, never mind, hold on. One more thing that we didn't talk about. Let's see, so we rotate 90 degrees. That's not really important. We want to know which statement is true. So this one starts talking about angle measures. And this is kind of important. If you just rotate something and it is, where's my answer? If it is congruent, it means it's the same shape, same size, right? So if it's a rotation, the angles don't change, okay? But even if it wasn't congruent, even with the dilation, you still have similar figures which keep the same shape. So the angles don't change there either. So on any of these, if it starts talking about the angles changing, that will never be a true statement. Okay? All the transformations we've done do not affect the angles at all. So let's look. So the angle measures are not equal. That can't be it. The sum of the angle measures is less. Again, if the angles are less, that would change the shape. That's impossible. Each side length is 2 times as much. Well, 2 times, that'd be a dilation, so that can't be it. And they have to be congruent to each other. Well, we know on rotation does leave congruent shapes, so there's our best answer. Let me make sure there's nothing else. No, let's see. There's some angle stuff on here. We just talked about angles. No, this is just rule stuff. Okay, so the rest is pretty straightforward. So there you go. So follow the chart. That's got most of the rules. And remember, no matter what kind of transformation you have, the angles will always be the same on both shapes. Okay, there you go. Have fun with that.